So, hey everybody, it's Dr. Peebler again. We're having another episode of Nurse and a Doc Roundtable, and I'm Dr. Casey Peebler. I'm an internal medicine physician and integrative functional medicine practitioner, and this is my colleague Jordan.
Hello, welcome back to another episode. So I'm a clinical nurse in RN, and I've had experience anywhere from emergency rooms to outpatient settings like a medical office, such as an Integra, and as well as with pediatrics. Personal interest in building biology and EMF.
EMF building biologist in training, I might add.
In training, yeah.
So I'm looking forward to seeing how that goes. Hey, so one of the big things that I wanted to have happen, which is starting to happen, is for the audience to actually ask questions. And one of our loyal followers has asked a barrage of questions, and I'm going to try my best to answer these questions. Now, there are several questions, so I'm going to have to read them off. So this is from our
Big
friend
Kenny.
Ray Kinney, and he goes by the screen name of Ray Kinney 9907. And so his first question is that uh, mercury and lead adversely affect the brain tissue and could harm mitochondria. Um, so I'm guessing he meant, does that affect the brain tissue and harm mitochondria? So yes, that it does do that. It definitely affects neural tissue and mitochondria. It works through, the major mechanism that I'm aware of that it works through is through oxidative stress. And when you have oxidative stress, it leads to a redox imbalance. And when you have a redox imbalance, you will deplete intracellular antioxidant systems, which will then, the free radical damage will actually damage proteins, carbohydrates, lipids, et cetera, that are either in mitochondria or intracellular that lead to mitochondrial damage. And that will disrupt the intermitochondrial membrane potential. That will generally lead to leakage of intermitochondrial proteins, in particular cytochrome C, as well as mitochondrial DNA into the cytoplasm, which will then kick off what they call the inflammasome. And the inflammasome will then lead to either cell death and or a lot of inflammation in that area. So that's really the mechanisms of how it does it. Now, I asked a follow-up question as well, and I'm going to skip to the bottom one, which was misfolded protein or protein aggregates, seem to be involved in a lot of different pathologies. True. If lead can replace zinc in forming proteins, that is no longer able to function. So yes, and as a matter of fact, I can send the paper that I found, or the papers that I found that have shown this, is that when you have heavy metals of any type, they can replace ions that are associated with proteins or minerals that are associated with proteins and the folding of those proteins. And it can lead to the inability to, once a protein is misfolded, being able to refold, and just an inability to fold that protein, which will lead to disease. So yes, it can. And then the other thing you mentioned is glyphosate able to, glyphosate is able to replace glycine, the amino acid, and cause chains to misfold. Can this problem add to the mitochondrial dysfunction pressures? Absolutely. No questions. I mean, enzymes are proteins, and proteins have primary, secondary, tertiary, quaternary structures. And when you're not able to fold correctly, they're not able to function correctly, and therefore their performance will be degraded. No question. Another question you had asked was regarding given increases in D3 as a strategy towards reducing a lot of diverse disease, true, and the resultant increase of gut absorption of calcium in the soft tissue, what transporters are involved in moving to reduce excess calcium and get into bone quickly to avoid calcifications of soft tissues? I understand that K2-MK7 is such a molecule. Are there others? So this is a pretty deep question, because first of all, in order for you to have calcium reabsorption in the gut, when I was in medical school, the only thing we really talked about when it comes to vitamin D is calcium metabolism and how that is screwed up. And it requires a series of enzymes. So vitamin D3 by itself is not going to do that. Vitamin D3 has to be enzymatically changed. In particular, it has to be hydroxylated. There's a 25 hydroxylase enzyme that's in the liver that has to hydroxylate the 125 site, and then it has to be also hydroxylated again at the first site, which is done in the kidneys. And so if either of those processes are not happening, you're not going to have proper calcium absorption. And that is a tightly coupled and tightly regulated process. And you're in general not going to have excess calcium absorption, even with very high vitamin D levels. I mean, I have to be honest with you, like I work in a hospital and I have people who come into the hospital all the time with hypercalcemia. And it is a cause of hypercalcemia or high calcium levels in the blood, but I would say it's a fairly rare cause. And I could also say that of people that I've seen, now not many people have normal vitamin D levels, but of the people that I've seen who have what is considered by modern medicine high vitamin D levels, I have not seen hypercalcemia be a common thing. So I hope that helps with some of the fears with increasing vitamin D levels. Number one, when we check vitamin D levels, we check 25 hydroxy. We do not check 125 hydroxy in most patients unless they're a renal patient generally. So, like I said, that process is very tightly coupled to make sure that you don't have hypercalcemia, because that is a problem. And calcium dysregulation is something that you do not want to have. Now, on the second question of whether or not there are other things that are known to inhibit calcium absorption into soft tissues, I'm not aware of any. But you did mention vitamin K2, MK7. There is MK4 as well. There's two different versions. I think the difference is the half-life of how long it hangs out in the bloodstream. And I think that, you're going to get those in certain foods. Do you want to be taking a bunch of MK7 or MK4 supplements? I don't think it's horrible for you. I think it's always better to get these things from food. And we can talk about later what foods in particular are high in vitamin K2. If you've ever heard of the Weston A. Price, kind of movement, they talk a lot about factor X, or later became vitamin K2, and what sources are high in those things. I hope that answers the questions to some degree. Let me see if there's any other questions he had. He had a lot of questions, and they were all good, high level questions, Ray. Let's see here. If lead, I'm just going to say, if a heavy metal is mobilized from bone stores when the body comes under stress, as calcium is sought to deal with the stresses, does K2, MK7 also transport iron, heavy metals back into bone? I'm not familiar with vitamin K2, being non-discriminatory towards non-calcium metals or minerals. I would like to look further into that. And in terms of the body's ability to deal with the stressors of, a heavy metal being liberated from fat, which is where the majority of it is, or bone, that's going to be more your antioxidant systems, which is kind of goes into your second question. Since lead is suggesting reducing both glutathione and GABA, I would say that, glutathione or other systems of detoxification would be more involved with that. I think that I don't exactly know how, heavy metals could lead to decreased GABA, but GABA is stands for gamma aminobutyric acid, and that's a neurotransmitter. And if there were neuron damage, I could imagine that could lead to decreased GABA. If there's other mechanisms, I'd like to learn about them. So, and does that put added pressure on mitochondrial dysfunction? Definitely, whenever there's redox imbalance and there's a depletion of glutathione, there's no question there's going to be downward pressure on mitochondria and increased oxidative stress, which leads to mitochondrial dysfunction and later inflammation, which lead to disease long term. So I hope that those answer your questions, Ray. Those are excellent questions. You're obviously a very smart person to be able to ask those kind of questions. And I hope those answers were adequate. If they're not, ask more questions and I'll try my best to answer it in a different way. That is the only, right now, the only source of audience questions. What a great start. Jordan, did you have any other questions or topics for discussion, or even questions about his questions and the answers that he did?
Found it interesting. I think it's a subject that we've touched on before on the channel. You've touched on before about vitamin D, as he's mentioned, an increase given increases in vitamin D3 as a strategy to reducing a lot of diverse disease. Um, I think sometimes we've looked at vitamin D as the principal mediator to reduce these diseases, reverting them. But I understand sometimes now in the literature, it's being looked at as rather a proxy for sun exposure instead of the
Yeah,
principal.
that's a great point. So, vitamin D, just so we're all clear, and we'll talk about this later in the series, like with pictures, that help understand the mechanism. But, vitamin D is a steroid hormone, and it is based off of the cholesterol backbone. And there is a non-enzymatic, which means there's no enzyme required for this to happen, for this change to happen from cholesterol to vitamin D. The only thing that's required is UV light, in particular UVB light. So when we increase vitamin D, it acts. First of all, it doesn't just increase vitamin D. It increases vitamin D3, but it also increases all these other vitamin D analogs, which also have physiologic effects, which we'll talk about in detail like later in this series, right?
And
But
sorry
yes,
to ask,
go ahead.
when you supplement with that oral vitamin D, just so we're all on the same page, you are not getting all those analogs as if you would
No,
from the
you're not. You're not getting all those analogs. Some of them you may due to conversion of liver and basically like when vitamin D gets changed in the liver through the P450 system and the different detoxification systems, different molecules get changed in the liver a lot of times or metabolized. So you get some of them, but not all of them. And yes, it is a proxy for sun because, as a matter of fact, it's probably our only proxy for sun. There is no really other way for me as a physician or as a medical provider to tell how much sun you're getting, unless other than a vitamin D level, a 25 hydroxy vitamin D level.
that's
So if you're
definitely
supplementing, it's messing up my ability to know how much sun you're getting because there's many other benefits besides vitamin D from sun, right? And then before you go ahead, I'm going to say that you also mentioned that vitamin D is just a means to get other benefits, right? So yes, it acts directly upon mitochondria as a hormone. It acts directly in the nucleus in the DNA as a hormone. It it has all kinds of impressive benefits of how it acts through. It doesn't necessarily act directly with vitamin D itself. It acts through the pathways of gene expression, acting as a steroid hormone.
so we're going to discuss how when you get sun, you get all these analogs, but when you supplement it via oral means, you kind of missed out on most of them. You get a little bit of them through the liver. So would it be a more advantageous strategy to then use something like a spurty lamp, like the UVB lamp? Would you get the analogs then?
Yeah, it's a great question. So yes, you would get the benefits of the analogs if you use a Spurdy vitamin D lamp. Do I recommend that? No, I don't recommend that. Not because it's bad for you, but because I always recommend getting it from nature, right? So a Spurdy vitamin D lamp, it's a great source of equipment. I have two of them myself. I do not routinely use them or recommend that they get used because we live in South Florida. We live at the 25th latitude. We get sun the vast majority of the year. There's only we get vitamin D all year round, right? But it's just there are some periods of the time during the year, even for us South Floridians, that it is a little bit hard to get a meaningful amount of vitamin D. And in that case, I think it wouldn't be horrible to either supplement or use the vitamin D lamp. However, UV light does not happen in nature in a vacuum. There is not just, only a UV light source. When you get the sunlight, you're getting 40% infrared A and more than 40% infrared and red spectrums, right, from the sun. It's always balanced. And so I do not recommend using a spurty lamp when you're not using at least red light like at the same time with a spurty vitamin D lamp. I don't feel comfortable recommending that. Just only UV, A or B. Does that answer your question?
Yeah, it does. Gives a clear understanding that really supplementing orally as with vitamin D, it is helpful if that's like the only thing one can do, but we really want to try our best to get out in the
Yeah, I
sun.
mean,
Right?
would I prefer a patient to who cannot get sun or doesn't have access to a spray lamp to not supplement? No, I would prefer they supplement because it's better than nothing, right? You're getting a lot of the benefits. You're just not getting all the benefits of vitamin D itself. Plus, you're not getting any of the benefits of the other spectrums of light that are outside, right? But for example, like with my hospitalized patients, I give vitamin D. First of all, I'll check vitamin D on a lot of patients, especially people who have, infectious problems, particularly respiratory infectious problems. I'll check their vitamin D. Classically during COVID, I was checking vitamin D on every single patient, and I would give mega doses of vitamin D to patients, to the right patients. Um, but those are patients who are stuck in a hospital, who can't get outside, who don't have access to a sporty vitamin D lamp, who need support now. And so there are exceptions to the rules. It's just that you're better off using nature. You're better off using the sun because there's no better light in the universe than that light for the human being.
Right. And apart from just vitamin D, there's tons of plethora of other benefits. Do you want to talk a little bit about the endocrinology benefits or effects that the sun has on us?
Sure. I mean, uh, this is a very long-winded topic, but I think the easiest way to probably get into the hormone discussion is probably through POMC. So POMC is a gene product uh, that stands for pro-opiomelanocortin. Okay, POMC, and it is basically a sequence of the genome uh, that gets cleaved into several different other proteins, and it codes for many hormones, including ACTH, which is responsible for increasing your cortisol, alpha MSH, beta MSH, gamma MSH, etc. So that's an easy way to talk about how sunlight affects your hormones. Is through POMC, and POMC is liberated by exposure to UV light. So that's probably the easiest way to jump into it. When we get into further discussions, it will be probably a little bit too high of a level for this format without at least laying that background and laying that groundwork through the lecture series. If you want me to be honest with you, did that help at least?
Yeah, yeah, it makes sense.
Sure.
And I think it's something that we definitely gonna talk about more in the future, but it is a good thing to have in mind because sometimes we could, I think, in general senses, because of the literature where we think about mitochondrial dysfunction and only in the context of neurology or only in the context of certain diseases, but reality, it applies to almost every system in the body.
True. Yeah, cortisol is definitely the master hormone, and cortisol is set by light cycles. Your cortisol generally is higher in the morning and it decreases at night, and then the other end of the coin is the melatonin story, which is also a hormone, and it is lower in the morning and increases at night. Right. So it's kind of like two sides of a coin. And there's robust literature to suggest that. There's a lot of cool diagrams that I have during our series as we go forward that suggest that as well. So it's not just about getting vitamin D, it's about how the sun and being exposed to natural light throughout the day sets your circadian rhythm. And then that circadian rhythm actually is what's responsible for releasing certain hormones at certain times of the day. Pretty cool.
Wow. And that also I know you um touched on this subject in one of your recent videos about the human battery, right? The sun recharging the human battery. Can you talk about that a little bit and really what is the human body, what battery
Sure.
exactly like the exclusion zone?
Sure, man. So this is obviously another topic that I can't wait to get into, like when we get to this series, this part of the series, because this is for me like the more exciting stuff. The other things are just kind of like background information, so I understand like how we do this, right? But basically, how do I start this? So, you're made up of, cells, and in those cells you have cytoplasm, and that cytoplasm is basically water. And then you have a bunch of, proteins and fats and nucleic acids and stuff like that that are compartmentalized in different organelles, right? And so it used to be thought of that the cytoplasm and the intracellular and extracellular water was just there to provide a medium for these proteins to interact and so on and so forth. And it was basically inert and it had no function. And we're coming to find out that that is not true. As a matter of fact, it's the function of the cell is dependent on the intracellular water, as well as water in most places in your body. And it's not just a swimming pool for proteins. It actually powers those proteins through building something called the exclusion zone. And there's a professor up at the University of Washington, Gerald Pollack. He's a professor up there, and who's pretty much coined the term the fourth phase of water. Most people know that water has a liquid phase, a solid phase, and a gas phase. And he's able to find a fourth phase of water where it acts almost like a gel. And water is also bipolar. It is a dipole, so it has a positive side and a negative side, electropositive and electronegative side. And when you're put under the right environment, you can actually create something called an exclusion zone, or the fourth phase of water, or coherent domains is another way it's been showed in the literature. And basically, it is a battery that is formed. There's a positive and a negative based off of water. And when that happens, you're able to conduct charge. They've actually been able to take these exclusion zones and actually put electrodes in there and power like light bulbs and stuff like that using the exclusion zone. And it's basically it's potential energy that is used to power the system. It used to be thought of that ATP, or adenosine triphosphate, was the only energy currency in the cell, and that's not true. As a matter of fact, I don't know the exact figures, but there's a prominent scientist,
Gilbert Ling.
Gilbert Ling. Yep, Dr. Gilbert Ling, and he was able to determine that if you just went off the ATP by itself, you would have like a 500-fold difference in missing energy that's required for the body, right? So this exclusion zone, these coherent domains, this fourth phase of water actually helps answer that question and how that works. And these coherent domains and exclusion zones are principally created via light. In particular, Dr. Pollack has studied different frequencies of light, and we're going to talk about in the mitochondrial series the electromagnetic frequencies and electromagnetic spectrum, and how it goes from UV to blue to green to red to infrared, far infrared, et cetera, spectrums of light. And he's able to determine what particular wavelength of those lights are going to build the exclusion zone at the greatest extent. And that is part of the story of how you build the human battery. That is part of the story of mitochondrial redox, and that is part of what I wouldn't say part. It's actually going to be a large portion of what we're going to talk about later in this series of how to build the human battery. This last video that I just put out was really about how I personally had discharged my own human battery over the course of the last 7 days, and how I was using the analogy of these, I think I came up with 10 things that were off the top of my head that were able to tell you what was able to discharge that battery. But I, and basically, doing the opposite of those things was going to help rebuild it, at least in theory. And so, yeah, I mean, it's probably one of the more interesting pieces of this story. I think that a lot of us who are trained, at a university, get a very, how do I say it, incomplete and an old version of what biology, biochemistry is, cell biology, et cetera. And the new literature is it's beyond fascinating. And it is probably some of the more interesting pieces of this story.
I think I heard, don't quote me on this. I'm going to have to recheck and make sure that I'm right here. But I believe it was the head of department at UCC Medical School that mentioned that 50% of the information in medical books, textbooks, is wrong or yeah, it's wrong. And then when he was asked about the consequences, he says incalculable.
Yeah. Yeah. So, even when you're in medical school, okay, like when I was in medical school, like even when I was in medical school, they told us by the time we're done with our training, which for me was 7 years, by the time I was done with my training, although to be fair, my training's never done. I mean, you're always learning these things. But my
That's the
formal
right
training,
answer.
my
Yeah.
my 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 formal medical school and residency training, by the time you were done with that, it would like 90% would be outdated, and that's pretty scary, because if your doctor went to medical school and let's say the 1990s, and that individual is not keeping up with the medical literature, he or she is really behind, right? And I can tell you that I had, my undergraduate degree was in biochemistry, and I have a strong interest in biochemistry and cell biology. And I think that it really helped me when I was in medical school, because you have a lot of that when you're in medical school. But once you're done, once you're in your like third and fourth year of medical school, that's pretty much over. You know what I mean? Like you pretty much are done with that, piece of it. And it's not that you don't know it, it's just that you're not continually really pushed towards learning more things about that, or learning, the up-to-date science on it. And it may, it probably seems to a lot of my colleagues that it's not really helpful for practicing clinical medicine, which I wholeheartedly disagree with. And then in addition to that, when I went through my IFM training, the Institute of Functional Medicine training, one of my favorite modules was the energy module. I think they've renamed it to something else now, but it was called the energy module. And it was a at the time it felt like a deep dive into mitochondrial medicine and how it related to medicine. But to be honest with you, I'm not saying don't do the IFM energy module. It's a great, I see it as a great starting block. I think that the information that's out there, it puts that module to shame. You know what I mean? It just is. It's almost too basic. For it just is. It's too basic. Like there's just so much more information out there, and so I'm not sure if I've shown the slide yet in the series, but basically, it used to be that I think there was a graph, and it was kind of like genomic medicine, research papers on the human genome, right? The nuclear genome. It was like it went up to like this, and then it like once the genome was solved, then it like kind of started going like this, and it's kind of like sloping down like this. And mitochondria, it's just like a small slope, and it's kind of like going up like this and this like this, and it's just like that's where it's headed. You know what I mean? Mitochondria. And so if you're not, I don't know, man. I think that the more I read, the literature I read, the more I'm like just blown away, by what's out there already, and to think what we'll be discovering in the next coming years. I just can't even imagine. And you're right, man. Like you're either if I mean, like Jack Cruz talks about it, a half truth is equivalent to a full lie, right? So if you only know half the story, or if you only know a little bit of the story, and you're not leveraging it to the full extent, you're not able to help patients to the greatest extent. So I
Yeah.
hope that helps
Yeah.
answer
I
that.
think that's one of the biggest challenges I think today patients um, face is really finding a doctor that has that big picture understanding. May not understand all the intricacies between like light, EMF, um, environmental toxins, and their specialty, but at least having a big picture conceptual understanding. Like, what's your comment on that? Like, imagine having for example, endocrinologist, cardiologist, neurologist, or etc. But they're missing some of these pieces of the puzzle, like let's say EMF, the light story. How, if we had to quantify that, how substantial is that to their practice and the advice that you're going to receive at the other end as a patient?
Yeah. Well, these are obviously great topics and great questions. Wow. What I would say is this, man. In conventional medicine, as an internal medicine doctor, like I know a lot of things. Like I can help a lot of people. I know how to perform a lot of workups and do a lot of treatment. You know what I mean? But if someone comes in with a gastrointestinal bleed, I'm not going to do it on my own. I'm not going to go do an endoscopy on a patient. Like, I'm going to consult gastroenterology, and they're going to come and help me with that particular case. If someone comes with an acute MI, someone has a heart attack, I'm going to consult cardiology. I don't have the skills or the knowledge necessary to perform a cardiac cath. I don't read nuclear stress tests. I don't, even though I have, training and how to read x-rays and CTs and MRIs. I'm not a radiologist. I have to rely on their expertise in that field, right? And that requires humility, and it requires knowing what you don't know. And I think that when it comes to, non-conventional medicine, I think the most important trait of your doctor or your medical provider is being open-minded and willing to say that I don't know the answer to that. I'm either going to find someone who's going to help me find the answer to it, consult someone else, or I'm going to look in the literature myself with what I understand and look at those answers. But I think that what happens at a lot of times, the people who come into my world, in the alternative space, my functional medicine clients, most of them have been shamed, have been belittled, have been invalidated completely with their complaints, right? Like if someone, one of my favorite topics that people come into my clinic with or into the practice with is fatigue, right? Because fatigue is like this like big black box of like differential diagnoses, like the things that it could be, right? And unfortunately, like for whatever reason, man, like this is just the trend that I see like everywhere. It's like if someone comes in with this chronic fatigue type syndrome, like they either have a thyroid problem, right? Like they check a TSH, thyroid stimulating hormone. And if that's normal, which is a completely inadequate way of looking at the thyroid, right? They are depressed. And if they're not, if they say, doctor, I don't feel depressed. Like I just feel tired. You know what I mean? Then it's like, well, you're just getting older. Just deal with it. You know what I mean? Like, it's like, that's the only 3 boxes you can be in. You can either have a thyroid problem, you can have depression, clinical major depression, or you can just be getting older and you have to just deal with it. And it's like, how awful is that? You know what I mean? Because it's so not true. You know what I mean? There's so many different things it could be. You know what I mean? Like if you're not even checking a CBC and making sure the patient's not anemic, you know what I mean? You could have chronic fatigue from that. Like something as simple as that. You could have horrible renal failure, and be uremic and have, these are things that conventional doctors could find, you know what I mean? But like if you only have your mind open to the fact that if someone comes up with fatigue, which is a very common complaint to a medical doctor, right? As hypothyroidism, looking at that from a 20,000 foot view, not even adequately, major depressive disorder, or you're just getting older, deal with it. I mean, if your doctor's telling you that, I'm sorry, just find a new doctor. You know what I mean? It doesn't have to be me. It could just be literally anyone else who's like, but open-mindedness and the willingness to listen to you and like validate that you actually are having a problem. And if I don't know what it is, like I'm going to help you find it out by either consulting somebody who does know or looking it up. Like that's where I see the biggest problem right now in healthcare.
I think it can be said that genuine wisdom cannot exist apart from humility. Without humility, there cannot be genuine wisdom.
I think there's a lot. I think that's wholeheartedly true. When people come into my office, like I don't know everything. I don't pretend to know everything. I never will know everything. I'm very curious, and I will scour the earth to find answers. But if I can't, I'm going to refer them to someone who can help me. You know what I mean? Because it isn't about me. It isn't about the practitioner. It's about the patient. It's always about the patient. And if it's not about the patient, it's about you, then you're in the wrong field, dude. You need to get some humility or find another profession, using your degrees.
I think we can both agree on this, that there's few things as disheartening to have a patient come to you and they're just completely disarmed because they've been told, like you were saying, well, this is how I was born. My genetics told me this. I'm just getting old. I have to deal with it. I have to put up with this for now. Being on the receiving end of that, of a patient coming in, I think that's one of the most disheartening things to hear.
Oh, it's horrible, man. I've heard horror stories, man, about how they've been treated by their doctor. And they've been, like I said, they've been shamed, they've been belittled. They don't even look at their patients, like they're on their computer, they're like, writing their note, their note is more important than actually looking at their patient and actually like being present with them. And you know,
With
it's go ahead. Sorry.
no, my bad.
No, it's disheartening, and there's just no question. It's disheartening, and I feel for the patients, who have to experience that. And unfortunately, it's a very common thing. I think that the bar needs to be raised for healthcare. Unfortunately, due to powers that I can't control, doctors are they're overworked. They're underpaid. I know it sounds crazy, but they are. They don't hardly make anything compared to what they used to. They have to see like 40 patients a day to make ends meet. They got all these different people. Their overheads are crazy. I'm talking about mostly outpatient doctors. Their overheads are crazy because they have to fund all the staff. And they have to have staff that are literally like begging insurance companies to pay for these routine tests. It's just they're only able to see people like 5-10 minutes at a time. Like, what can you really accomplish in 5 or 10 minutes? You know what I mean? Like, my consults go over an hour. Like I usually charge an hour, but like, when you work for Integra, man, like I would routinely go an hour and a half.
Yeah,
And not
yeah,
because I wanted to like spend that much time, it's because it just takes that much time. You know what I mean? To like get the answers, you know what I mean? To give the education, it just takes time, and when you're so I don't want to be all like doctors are horrible people. They're not. Most of them went into medical school and for a good reason. Now, most of them are very closed-minded, unfortunately. Science, we're supposed to be open-minded, asking questions and having hypotheses and have those hypotheses, tested and so on. But it's just the system is broken, man. There's just no question.
I think something maybe we can do in the future is have a series or episode dedicated to kind of giving the right tools to patients on how to find the right provider. Given there's so many choices. Maybe in your local area you have like 50 different PCPs. Some of them are covered, some of them are not. Which one do you want to go to? Does it just matter because they're covered by insurance? And I think picking the right provider I don't know if you agree with this. What do you think? Could be one of the more important things that you should know how to do as a patient.
Well, I mean, I don't disagree with you. I think who is helping you with your healthcare on this journey of life is very important. I think it's easier said than done. Like, I don't even know off the top of my head how to find a good PCP. You know what I mean? I'm just being honest with you, like right here
Yeah.
on this episode. Like, I mean, the only way I would know is if people that I interact with, like throughout my residency training, or people who I interact with in the community, and kind of know on a personal level. I kind of like am able to kind of like talk about like my interests and see if they're, like, just kind of like putting up the stiff arm, just like, oh, I don't want to know anything about that, or if they have a little interest. I know it sounds, I don't know, how do I say this? I mean, this is coming from a person who's board certified. I think that being board certified doesn't make you a good practitioner. I think that it's a test that we all take, and I think you should take it. But if your doctor or provider is not board certified, I don't think it's the end of the world. I think they can be a great human being and they can be a great medical practitioner and not be board certified. There's a lot of factors that lead to people not being board certified. Sometimes language barriers. There's a lot of foreign medical graduates and stuff like that who are excellent doctors. I mean, fantastic doctors that may or may not be board certified. So if you're looking at doctors only by the fact that they're MD, DO, and they're board certified, I think that is a very superficial way of looking at whether or not they're a good practitioner. I think asking at least like the questions that if you know people who have these other practitioners as doctors, I think that's important to like say, hey, like I'm not really interested in taking a lot of medicines or doing a lot of conventional treatments. Is your doctor open to that? You know what I mean? Is he even going to entertain, he or she going to entertain that? You know what I mean? And if they're not, like, I would just say next. Like, there's just most places are going to have enough people that you can have at least some semblance of a selection process. If you're in a very small town and you only have one, then I still don't think you're SOL. I think that you can still like, I think you can still like either find people via telemedicine, I also don't think that if you're an integrative or functional medicine doctor, that automatically means you're a good practitioner. I just don't. I think that you can, I think it can mean you're a good practitioner. I think in general, it means you're more open-minded. I think in general, it means you're going to listen to the patient, and at least like give them the benefit of the doubt that you actually are experiencing what you're experiencing, and try to do a very deep workup for that patient. But it doesn't necessarily mean that they're good. So I think that actually, although I would love to do that series, Jordan, I think it's a great idea. I think it's going to be harder to answer those questions than believe it or not, it may be. And even for me, in the field, I think it's harder than yeah.
Yeah, it is a vacuum in medicine because if you think about it, in other fields, industries, services that people receive, let's think about like education. Um, we all know what would be a good school, what would be a bad school, right? We all know if I have a problem with my car, what would be a great mechanic or a great place to take it. But it's really difficult, from the healthcare perspective to find and identify what is that right care for one.
Yeah, man, no question. No question. Well, hopefully we'll be able to explore that in greater detail, later. Um, I think that, I don't know how long we've been going, but we probably should wrap up, don't you think?
Yeah.
It was good talking to you as always, my friend. And I hope we can have some more audience engagement. I think raise questions, man. Just keep them coming, man. I'll try my best to answer them. I can't always answer them, all of them, because they're very deep questions, and I had to actually search through some medical literature to answer some of them. But iron sharpens iron, man. So those good questions actually make me a better practitioner and get me better knowledge, and then I can hopefully share that with other people. So keep them coming, and I hope we can have some other guests and viewers ask some other questions, and we'll do our best with our knowledge base. And if we don't have it within our knowledge base, we'll look it up, and if we can't find it, we'll let you know we don't know the answer. So any last remaining comments, Jordan?
No, just emphasizing what you said. Uh, Keep it coming. Continue to tell us what you guys want to see, questions, concerns, etc., etc.
Got it. All right, well, thank you as always, and we'll until next time.
Until next time.